Okay, welcome back. Happy, what's today? Friday. Happy Friday. Today, class number 8, we are talking about solving other types of equations. The demo, which is the part that I kind of lead up here, is quite long. We're going to like blaze through this thing. I suspect that most of you will have seen most of it before, so I'm going to show it to you kind of quick and hopefully give you plenty of time to do the activities. Just looking ahead, we can see that Monday is our review day for test number 1. I don't have any agenda for that day. You're just going to come in and work on practice problems. Our very first test of the semester is coming up Wednesday. It is on all of the material classes 1 through 8. That is everything from the first day through the end of today. Okay, end of today is the end of the material for the test. In terms of, one thing about the quiz here, I haven't graded the quizzes. I barely started grading the quizzes. I'll give them back to you on Monday. You'll have it with the feedback before you take the test on Wednesday. In terms of resources for the test, the best way to study for the test is to do all of the homework, but I've also got here a, where is it? A study guide. It's on page 50. You don't need to go here now, but it's on page 50 in the back of this packet that you have. And on the study guide, it says to be prepared for this test, you should be able to, and there's a long laundry list of skills that I want you to have to come in prepared for that test on Wednesday. So you just go through them one at a time and you say, oh yeah, I know how to do that. I know how to do that. Oh, I don't know how to do that. Let me find some practice problems on that topic. Another resource for you is on the very next page, something called sample test problems. And so I don't know how many there are, something like 6 or 7 or so practice problems. I'm not saying like this is the only thing you should do. I know that students really like sample tests, but like just because you get like 100 on this doesn't mean you're getting 100 on the test. This is just a small collection of the kinds of problems that you might see. I'm pretty sure there's an answer key a few pages down the road in the packet for this thing. And another resource that you'll have for this is actually videos on YouTube. So for example, this first one says describe the following sets. Write the interval 1, 2 and set builder notation. And if you go on to our Moodle page, one of the things you'll see is sample test 1 videos. That brings you to a playlist, which is this, sample test 1, problem 2, problem 3, etc. There's no video for 6E, is a little note up there. And if you click on one of the videos for the problem that you're interested in, you'll see something like this. Well, I don't want to ruin the answer for you here. It's like a spoiler, so we'll let you guys try the problems on your own. If you get stuck, you have 24/7 access to me solving these problems, okay? So I suspect what will happen on Monday is we'll just talk a little bit together for maybe the first 10 minutes of class, and then the rest of that class you can just work on these problems. But I'm hoping that some folks will get a jump start on things this weekend and start practicing before Monday. Questions on any of the resources you have? Oh, all right, good. So at the moment, 208 views. I'm expecting that to get to 2,000 by the end of this weekend. So get cracking, right? Share it with your friends. Yeah, okay. All right, so I think we're here on page 43. And let's see if we can kind of blitz through all these different kinds of equations. Okay, first one. Oh, 2 other announcements actually before we jump in. First one, some of us signed up for My Math Lab with a free 2-week trial, and that's groovy, but for some of us that 2-week trial is ending very soon, and so I just want to put out there that I'm hoping that we can, if we are on a trial, that we'll be able to make it a legitimate, you know, like semester-long purchase of this access code. So just so nobody's surprised by it, if you haven't paid yet, the bill is coming due. It's a 2-week thing that's ending soon. And then the other thing, speaking of My Math Lab, I had somebody email me, I think yesterday, and said, hey, I think I got the right answer to this problem on My Math Lab. It was expecting the coordinates of a point, and I wrote the coordinates, but I didn't put the parentheses. And so, of course, it marked it wrong because it was expecting parentheses. And so I said, no problem, I'll take care of it. And I just, I can go in and I can award credit for an individual problem on any of your assignments. So if you make some silly mistake and you know, like you got the right answer, it says your answer is this and the right answer is this, and they're the same, but it's like some silly little notation thing or a comma or whatever, I don't want you to go crazy. Like if it's a short problem, then just redo it and don't bother me. But if like it's gonna take you, more than a minute to redo the problem, then send me an email. Hey, Ian, homework 7, problem number 4. That's all I need. I can take a look. You don't need to give me like the whole backstory of what happened. Just tell me which problem that you think you got. And in many cases, I'll say, okay, I got it. I'll give you credit for it. But in other cases, I'll say, actually, you missed the boat. You need to do this problem again because you don't understand one piece of this. Okay, but you can always send me an email about that. All right, so number 1 here, polynomial equations can sometimes be solved by factoring and using the zero product principle. And then there's this warning here. It says don't divide both sides by an unknown. So here's the equation, x to the 4th plus x cubed equals 6x squared. Really tempting. I'm going to write something and I'm going to cross it off. You can write it if you want, but you should know that it's about to get crossed off. Dividing both sides by x squared looks like it's going to clean this thing up quite significantly, which is a good thing for us, right? So if we divide, what do we get from the x to the 4th? X squared plus, and what's left from the x cubed? X equals 6. Super. And then you can solve that equation and you'll get, how many answers will we get from that equation? 2. You guys remember the power, highest power tells you how many answers. You will solve that. You'll get 2 answers. That's great. But how many answers does the equation have from the beginning? 4. And all of a sudden, we just lost 2 of them. How did we lose 2 of them? Well, we divided by a variable, and that's a dangerous thing to do. So I'm going to say don't do that. And instead, let's do this. X to the 4th plus x cubed. I'm going to move that 6x squared over by subtracting. And the reason I'm going to do that is it leaves what number? 0. 0 is generally a very good number to have in equations. And then I'm going to say let's factor out the greatest common factor. What is the greatest common factor of these 3 terms? X squared. Okay, and so we factor out x squared and we get x squared plus x minus 6 equals 0. Yeah, Ivy. Absolutely. So Ivy factored out x instead of x squared, but you can still factor out more. And so if you factor another x out of what you just said in the parentheses, you should get us to here. What we want to do is grab the greatest common factor. You grabbed a common factor, but let's grab the biggest one, the greatest one. Okay, that thing in the parentheses actually looks an awful lot like this blue equation that I have the x through now. In fact, if you just move the 6 over by subtracting it, you see it's that thing over there? Right, but what we lost when we did it the first way was that x squared in the front. We lost it by dividing by it, and then all of a sudden it disappeared. It's still there. Okay, this guy in the parentheses factors into its own 2 sets of parentheses. Again, some of us are really quick at this. Some of us take more time. Doesn't matter to me as long as you can get to the answer. I'm just going to write the answer. If you factor this guy, you should get x plus 3 and x minus 2. Okay, and then we're going to write down simpler equations. Again, this is our zero product property. I am multiplying 3 things together, and I am getting 0. What must be true about one of those 3 things? One of them must be 0, right? And that's all we're going to do. We're going to write down separate equations. I'll start on the right-hand side here. On the right-hand side, either x minus 2 is 0, or in the middle, x plus 3 is 0, or in the front, x squared equals 0. You got to write it. Every single one of these factors set equal to 0. Okay, and then we solve our equations again from the right. Here x equals 2. Someone else in the middle. X is negative 3. Over here, 0, right? 0 squared is the only number we can plug in there. So those are our answers. So the moral of the story, 0 is oftentimes a good number to have on one side of an equation. factoring much, much safer than dividing by a variable. How many solutions did we expect from that very first equation? 4. How many did we get? 3. Okay, I know I admitted that I lied to you on the last class, but actually I didn't lie to you here. Technically, when we take the square root, remember the thing we have to put in? The plus or minus, right? Like if I said, x squared equals 16, what are the two answers there? Plus or minus 4. X squared equals 0, what are the two answers? Plus or minus 0. It happens that 0 is the only number that compressed down to a single one. So yes, there are 4 answers, as long as we're willing to accept plus or minus 0 as being 2 separate answers. Okay. All right, number 2. The key to solving a radical equation is to isolate the radical and then raise both sides to the appropriate power. So here's our equation. X plus the square root of x equals 12. Maybe the first equation we're solving where the variable is inside of the radical. So we are isolating the radical. That means get this piece by itself. So anything that is not that piece needs to move to the other side. So we subtract x from both sides. Radical x equals 12 minus x. And it says raise both sides to the appropriate power. We're trying to get rid of the radical, whatever that means. In this case, what's going to get rid of the square root is squaring it. So we're going to square that side to get rid of the radical, and then we're going to square the right-hand side just because we have to do the same thing on the right-hand side that we did on the left. Okay, on the left-hand side, we get x, right? Square root of x squared just becomes x. On the right-hand side equals, let's see, 12 squared, 144, negative x squared plus x squared. Right? 144 plus x squared. Good. A couple people say no. You dare to question me? Do you know who you're talking to? All right, what did I do wrong? I know what I did wrong. You're calling me out, Jed? Yeah, I didn't. Yeah, I didn't foil. I did something that's really common. There's still people in this room that like to do that, and it just doesn't work. Don't do it. If you see 12 minus x squared, write it twice. You'll get it right. As soon as I write it that way, I think foil or distribute. It's not as simple as just squaring the two terms. Okay, so let's do this right. 144 minus 12x minus another 12x is minus 24x. And then plus the x squared. Okay. Again, I typically like 0 in these equations, so let's bring the x over to the left. 0 equals 144 minus 25x plus the x squared. Yep. Right, subtract the x from both sides. Okay, and then this is a quadratic equation. If it factors, then that's probably the best technique to use. Honestly, I don't think this one does. So what's the fallback for any quadratic equation? It's quadratic formula. So I'm not going to go any farther with this one. I'm just going to bail out and say use the quadratic formula. Not to say that there's no work left. There's still a couple of minutes of work left in this problem. But there's nothing new for us in this problem. Not anymore. And just one word to the wise here, just going back to that original equation. It might be tempting to take this thing and square both sides right now. And there's nothing wrong with that, honestly. I can square both sides. As long as I do it to both sides, we're good. You see a square root, you want to get rid of it. Squaring is the right technique, right? So on the right-hand side, that's easy. That's 144. What's the issue on the left-hand side? Is that right? that's it, then this technique is better than what this is that same mistake that we made before. You can't just square both of the things in the parentheses, right? What we'd really need to do is write x plus the square root of x times itself. Yeah. And so, sure, x squared is the first term, and plus x is the last term. That's nice. But then the outers, what do you get? X radical x. And the inners? Another x radical x, and they don't combine. You just get two of them. And so it's okay to square both sides. It's not illegal to square both sides, but it doesn't help us here, right? We made the thing worse than it was at the start. And so that's why getting the radical by itself first is the right beginning, right? Don't square it until the radical is by itself, because if you square too early, you introduce terms that still have radicals in them, okay? All right, next page. Okay, let's take a look at this guy. We're not going to read the hint right here. We'll just walk through it. Solve 3x to the 3/4 minus 6 equals 0. Let's see if we can solve this thing here. Okay, I'm going to treat this piece right here just like I treated the square root of x. If that were a square root of x, what would the first steps be? It's to isolate it, right? Isolate that square root. It's still the same thing. We're going to isolate that x to the 3/4. What needs to move first, the 3 or the -6? -6. Add that to both sides. 3x to the 3/4 equals 6. And then we can divide both sides by the 3. X to the 3/4 equals 2. Just going to leave a little space here. Equals 2. Okay, so we have isolated the x to the 3/4. Here's where the magic happens. If it had been the square root of x, we would square both sides right here, if that had been a square root of x. So what we need to do is the right thing to both sides that's going to turn the left-hand side into what? X. That's the goal. I want x equals. So we got to do the magical thing that's going to turn this left-hand side into just plain x. In this case, I'm going to write something that isn't going to work, so don't copy this. For example, I could square both sides. Is that legal? Yes, totally legal. Same thing on both sides. What's the shortcut for these powers? How do you smush them together? Multiply them, right? We know we're supposed to multiply these powers. And if you multiply those powers, what do you get? 6/4, which is 1.5. So you could have x to the 1.5, which is fine, but it's not x. I just wanted x. So the goal isn't to put a 2 up there. The goal is to put the magic number that's going to leave me with just x. What's the magic number that's going to leave me? It's 4/3. That's the magic number, because we know we want to multiply and end up with just x to the first, and 4/3 is the right thing. In English, what's the fancy word for 4/3 compared to the original 3/4? Reciprocal. That's the right power. Don't memorize, multiply or raise both sides to the reciprocal. That's not worth anything. Just think about what you are trying to accomplish. You are trying to make x. You know that whatever you put up there in purple is going to multiply by that power. And as soon as you've got that, you'll figure it out. Your intuition will tell you what the right thing is to put up there. Less memorizing, more intuiting. Okay, so we've done that. And then left-hand side is really just x to what power? Is 1, right? Well, that's the idea. You don't need to put the 1, but multiply those two powers and you get 1. That was the goal. The right-hand side is 2 to the 4/3. I mean, you can type on the calculator and you'll get some crazy decimal. I'm perfectly okay with you just leaving 2 to the 4/3. That's a fine answer as far as I'm concerned. If you want, you could rewrite it as a radical, because I know fraction powers means radicals. What's the index, the little number in the front? It's a cube root, right? The thing from the denominator. And then a 2 raised to the 4. Said another way, cube root of 16. Either way is okay with me. Okay, another word to the wise here. Totally legal to just raise both sides to the 4/3 at this stage. Nothing good happens on the left-hand side. I want the 4/3 to just cancel with the 3/4, but they don't. There's just a lot of gobbledygook in the way right now, which is why isolating is the right thing. Even back here, if we decided, oh, I need to add 6 to both sides, and then we raise to the 4/3, 4/3 here, 4/3 here. Again, totally legal. But what you want to do isn't allowed. What do you want to do on the left? I just want to cancel the 3/4, right? But what's getting in the way of doing that? The 3. The 3 is in the parentheses, and the 3 is going to be impacted by that blue 4/3 power. So it's not wrong, but it's not the best way to go about doing things. Okay? So put some lines through here. Okay, moving down. Number 4, absolute value equations. I actually want to make this one a little bit tougher than it currently is. Can you guys change this one here? You can cross it off if you want. Let's make it this. 2x plus 1 inside of absolute value. Let's multiply by 3. And let's subtract 4 equals 29. Let's try that. So we're replacing the one on the paper with one that's more complicated. Okay, the key when you see absolute value in your equation is to isolate the absolute value. Starting to see the trend here? Like we're isolating this thing that is the complication, and then we'll figure out what to do once it's isolated. Which moves first, the 3 or the -4? Let's add that 4 over. So we get 3, absolute value 2x plus 1 equals 33. Then divide by 3. Might be tempting to distribute that 3 into the absolute value. That 3 is outside, it's not inside. You bring it inside, you change things. So divide both sides by 3. 2x plus 1 in absolute value is now equal to 11. Good? Now it's the same as the original problem. So all I did is just give us the extra step in the front, just so we know what to do when there's other stuff. Okay. So absolute value equals 11. Suppose that that we cover up this stuff in here, and I just imagine that there's a single number inside of those absolute value symbols. What number can I put in there so that I get 11 as the answer? I could put 11 in there, right? Or I could put -11 in there. Everyone agree? This thing that I'm covering up is either 11 or -11, no other options. So those are the 2 equations we put, just brand new equations. Either the thing that I was covering up is 11, or the thing that I was covering up is -11. Those are the 2 possibilities. Notice what isn't in either of those orange equations. What's not there anymore for the first time in this problem is the absolute value symbols. We've dealt with it. We've already understood what the absolute value is telling us. It's telling us the stuff inside is either 11 or -11. So the absolute value disappears at that stage. Okay, and then you have 2 simpler equations to solve, right? So subtract 1, divide by 2, what do we get? 5 in that one. Subtract 1, divide by 2, -6 is good. Okay. So some people like to memorize, if there's an absolute value in the equation, you isolate it, and then you take the stuff inside and make it equal to the positive of the number on the right-hand side and the negative of the number on the right-hand side. And all that is great if you got it memorized. But I would much prefer that we just slow down and think about what we're doing. Right? As soon as we covered up that 2x plus 1 and said, hey, it's just a number, people realized that it's either 11 or -11. It's very natural to get to the end of this process. Don't memorize. Okay, I think that is good there. one small twist. I don't know if you'll ever see one of these in like the homework or on a test or something, but suppose it had been this. So it feels to me like this is just the same kind of thing. Either 2x plus 1 equals, 2x plus 1 equals 5, or 2x plus 1 equals negative 5, right? Isn't that exactly the process that we followed over there? Well, oh, thanks. Yeah. So what's the problem with that being a negative, Trevor? Yeah. So no matter what we put in here, would you guys agree that we're going to get a positive answer at the end of the day? And no matter what I put in here, whether I put a positive in here or a negative in here, I'm going to get something positive at the end. And so is there anything I can put in here that's going to give me negative 5 as the answer? No. So like again, I'm not a fan of memorizing. I'm a fan of understanding. This original equation has no solutions. There's nothing to do. Just look at it and say, oh, this is silly because you can't have the absolute value equal to, some negative number, right? Doesn't make any sense. Okay, so don't memorize procedures. Just think about what's going on. All right, next page. I think we've got two more things to think about. Again, we'll keep going through these quickly, and then lots of time to work on the activities. Okay, let's just jump to the equation, which is here. We're going to solve, or inequality, I should say. We're going to solve negative 4x is less than 8. Let's give this a shot. What's new about this? Yeah, the greater than sign. It's not an equation anymore, right? It doesn't say equals. It says, in this case, less than. Okay, you solve inequalities in exactly the same way as you solve equations, with one or possibly two differences. So how do I move that negative 4? I'm going to divide both sides by negative 4, divide both sides by negative 4, and we got our answer here. Let's see, left side is x, right side is negative 2. What's the twist? Yeah, it is currently a less than symbol. Yeah, flip it over, right? So that inequality switches directions. What was it that we did that caused this change in direction? Is we divided by a negative. That's the key. If you divide an inequality by a negative, change the direction. If you multiply an inequality by a negative, change the direction. Division and multiplication are basically the same thing. So I think that's written out up here. Multiply or divide both sides by a negative, reverse the direction. If you're dividing by a positive, don't do anything, just copy it, right? Multiplying by positive, copy it. Adding or subtracting doesn't matter, just copy it. It's the only two cases where you change the direction. Multiply or divide by a negative. Okay, let's make sure we answer this completely. It says write the answer in 3 different ways. Let's give that a shot. Okay, set builder notation. You guys remember that's the one with the funny braces in the beginning. First thing we write is x, and then we write a math symbol that, yeah, says vertical line, which means such that. So it's a set of all x such that, and then we pretty much just have to copy the inequality there. X is greater than negative 2. And then we draw the other braces. One summer, I'm going to sit down and learn how to draw one of those right-hand braces. I feel good on the left side, but the right side I just can't do. I don't know what it is. Just a block. I think it's just... Okay, that's set builder notation. Graft on a line, let's try that. Here's our line. We'll put negative 2 right there. You don't need to put any other numbers, really. Is negative 2 included or not? It is not included because this is a strictly greater than negative 2 as opposed to being greater than or equal to negative 2. So yeah, for me, I like the hollow circle. as opposed to like a filled in circle. Your book, I'll put it down here. I'm actually not a fan of what your book does, but your book just puts the interval notation symbol. Is it a parentheses or a bracket when it's not included? It's parentheses when it's not included. So your book would put that. I'm not a fan. I feel like that's really abusing interval notation on the number line. But okay, and then we got to shade the correct direction. So which way are we shading here? Oh, yeah, all the numbers bigger than -2, so shade to the right. That's it. All right. When you're shading, you got to have like a crayon or something, right? There we go. All the numbers to the right there. Good. You like the crayon? Yeah. Okay, and then finally, interval notation. Let's put that one as well. So -2, we want all the numbers bigger than -2. So I'm going to put a comma. Is the -2 the first thing or the second thing? First thing, because you always put the smallest number and then the biggest number. So because we're going forever, what's the symbol we're putting? Infinity, right? So put that. Yeah. No, this is a greater than. Originally it said less than. And then when we divided by the negative, we had to flip this and it became a greater than. So is this a matter of like reading the symbol, or is it, where are we losing it? -1 is greater than -2. -1 is here, which is less than 8. Yep, it works. Okay, and then the symbols. Infinity always gets what in a bracket or parentheses? Yeah, infinity always gets parentheses. -2, because it is excluded, gets parentheses as well. Okay. All right, and then last piece is down here. Okay, -6, less than x minus 4, less than or equal to 1. This is called a compound inequality because it is 2 inequalities in one. Really, this is saying two things. -6 is less than x minus 4, stop. And also, x minus 4 is less than or equal to 1, stop. So it's just two inequalities smushed together as one. We're solving for x. The only thing here, normally I would say whatever you do to one side, you do to the other. There are 3 sides in this case. And whatever we do to one side, we do to all 3. The goal is to get x by itself. How do you move the -4? Add it. But instead of just adding it to both sides, we'll add it in the middle. That's the goal. But then we'll add it to the other 2 sides as well. So add 4 to all 3 sides. Works exactly the way you'd expect. On the left-hand side, -2. That less than symbol, does it change direction like before? No, never with addition or subtraction. Keep it. In the middle, what do you get? X, right? That was the point, was to get rid of that -4. That less than or equal to symbol gets copied, and then 5. So there you go. So that's it. Just one more time for practice. Can you guys write interval notation for that one? -2 less than x less than or equal to 5. -2, parentheses or bracket, parentheses, 5, bracket, right? Just have to keep track of which one means include and which one means exclude. Okay, sorry for the long demo. Like I said, there are just a ton of different kinds of equations and then inequalities that we solved here. I'm hoping that a bunch of this is stuff we've seen before, because if this is the first time you're seeing all this, then this was done way too quickly for you. Activity starts right there. Just raise a flag if I can help.